Welcome to General Structures 2 and Lateral Forces Lesson 3 quiz, question number 6. And it asks, what method or diagram is used to solve a truss graphically? And if you remember, we did one of these examples. I have never done this in real life, and I am also a little bit intrigued by it. But I'm just so used to doing method of joints and method of sections. That's what I do. So anyways, it is D. I'm not going to go over this like crazy. The stress diagram. And it was one of the examples. I don't remember which. Actually, I can just go back real quick and find out. Graphical solution. Look at example number 3. In this same lesson. And it should be about 7 videos back or whatnot. And it'll explain how to do this. But if you remember, the method of joints is where you go to each joint. You figure out what, if it's in compression or tension. You usually start with your end reactions or your end joints. You go up to the next joint. You take that one, go over here. You'll end up being able to somehow isolate one of these. For instance, this, I try to diagram this as having only a y component. You know what this is. This is now a known, and therefore you can isolate this y because you know the components of this. You can isolate this y, and you can find that y, and that'll tell you this x, and then you can find that x, or that member, because it's only in the x direction. And you go from joint to joint, and you end up doing the entire truss, and therefore that's just an easy way to go about doing it. And I always feel the most comfortable going about doing trusses the method of joints, just because it's very, do this, you do that, and you do this, and you can very easily catch your mistakes early on if you make a mistake. And that's my preferred method 9 times out of 10. Now if you're going in, you have a large truss, and you just want to find out what is one member, where you want to check one of your other calculations, you can go back and use the method of sections where, let's see, you have a truss. Let's make it a little bit bigger. Alright. And you want to go in, you can actually just cut it through right there. You can then, usually 99%, I think maybe 100% of the time, have to isolate. You'll have this, you'll have that, and you'll have that, and you will have to isolate one of these. And it's pretty easy to do. You can either, if you sum the moments about this point, obviously these two are congruent, and therefore you can isolate that. You could also isolate about this point, and this member and that member forces are congruent, therefore you could isolate the third, and so on and so forth. Off the top of my head, I don't think you can sum the moments to isolate this right there, but you could figure it out in other ways. So I won't get into that, but I'm sure you could figure it out. Somehow you could, in the y direction, if you sum the forces in the y direction or whatnot, and you could get that pretty easily, since this right here that has no y direction or y component, and that member also has no y component. Alright, and the last is free body diagram, and that is just incorrect. It doesn't solve it graphically. You do need a free body diagram, if I'm correct, to use the stress diagram, but a better answer is the stress diagram. Alright, I'm not going to go any further. I will see you on the next question.